Hello friends, our project title is EEG based virtual keyboard control through an adaptive intelligence user interface. EEG is electroencephalographic signals which are used to control the virtual keyboard through an adaptive intelligence user interface, which we have introduced in our project for passing large amount of information to the virtual keyboard. In previously systems, we are using the brain computer interface system, which have very low bandwidth of communication channel, and we are interfacing the computer manually, which has very low, because of very low communication of bandwidth channel, we can transfer only less amount of information. But now in proposed system, we have introduced the intelligence adaptive user interface, in which we offers the multiple degree of freedom to the system, and which provides updated prioritized list to all the options for selection of BCI user, and which improves the information transfer rate. In our project, we are using the one software, Brainwave Visualizer, and the NetBeans tools. In the Brainwave Visualizer, we have to connect it to the Brainwave to the Bluetooth driver. If the Bluetooth driver is get connected to the Brainwave sensor, if the Brainwave sensor, we can see the waves here. And we have to see the attention and meditation level. If the attention and meditation level is more than 90, the letter which we want to get print will get printed. Here we can see the two things also. If we click on the burn, the ball we want to get burn, if we want to get burn, if we think like this ball should get burned, the ball will get burned if we have high tension and meditation level. And if you want to lift up this ball, if you want the ball to be stable at the same position, we can think, and the ball will be stable at the same position. And we can print the letter also which we want to get printed in the virtual keyboard using the NetBeans tools. In this NetBeans tool, we can run the program. Here the cursor is keep on moving. If suppose we are thinking to get print this P letter, in this P letter we have to blink, and the tension level should be high on this P letter. If the cursor is coming on this P position and the tension is very high, the P will get printed here. Same way we can give space and delete also. We can delete the letters in this virtual keyboard.
Now about the brainwave sensor. The brain is made up of nerve cells called neurons. At each end of every neuron, neural impulses are transferred to the next neuron in sequence like cardiac impulse. So each time this happens, a tiny spark jumps, and anytime a spark jumps, it produces a radio signal. These signals passed by the electrical impulses of neuron should be amplified greatly by electronic circuits for it to become a measurable signal. The EEG recorder collects the signals from the electrode which is in contact with the skin. Skin is nothing but our scalp where the brainwave sensor is worn. EEG is nothing but it is a technique which detects the electrical activity of your brain. Measurement of EEG. Values between 100 to 400 Hz will receive through the electrode. Normally, brainwaves are analog. They are alpha and beta waves. Through electrode, we will transfer signals to the computer using these waves. The electrode indicates the wave format of the brain, since brain signals are of wave format. Brain-computer interface. This is the BCI system, which makes the connectivity between the hardware and software. Electrode cap. Now here this is the brainwave sensor, which acts as an electrode cap, and this is the ground cable which is attached to your ears, and it gets the signals and passes the interrupt to the Bluetooth. This is attached to the ground cable. And here is the battery, which is chargeable, and when you switch it on and make the connectivity with the Bluetooth, the sensor works. This is a node which monitors the electrical activity of the brain, and this sensor makes the connectivity between the system with the help of Bluetooth. And that's all about our project. Thank you.